Okay, so we know from our SOHCAHTOA that tan theta is the opposite side over the adjacent side. Now if we have a look at our diagram over here, the opposite side over here is our y2 minus y1, and our adjacent side here is x2 minus x1. So in reality, our opposite over adjacent is the same as our y2 minus y1 over x2 minus x1. So that leads us to the relationship that tan theta, or the angle that our line makes with the axis down here, is also equal to the gradient of our line. So let's have a look at these examples here. Again, identify the key words. We're looking at the gradient of the line. So we know we're using our y2 minus y1 relationship, but we also need an angle. So first things first, let's try to find the gradient of our line. Or even we'll have a bit of a graph sketch here. So if we plot the 2 points that we're looking at, we can see 3, 2 might be roughly there, 5, 7 roughly there, and the angle that we're looking for is that one there. Okay, so the angle that it makes with the positive axes. So let's go back and work out that gradient. y2 minus y1 over x2 minus x1 is equal to our gradient. So let's keep writing it down and label our points 1 and 2. Doesn't matter which order we put them in. So we'll get our y2 minus y1, 7 minus 2 over 5 minus 3, and we'll get an answer of 5 on 2. So that tells me the gradient is 5 on 2. So that means that tan of the angle that the line makes is equal to 5 on 2. So to find the angle, we use our tan inverse relationship. So theta equals tan inverse of 5 on 2. And if we work out tan inverse of 5 on 2, we get 68.2 degrees. So what that means is that angle that our line makes with the x-axis is 68.2 degrees. Moving on to example 8, same thing, gradient of the line passing through the point. So we see that term gradient of the line, so we know we're working with y2 minus y1. The angle means we might need to use the tan theta relationship. So gradient is y2 minus y1 over x2 minus x1. Label the points, point 1, point 2. So we'll get our 5 minus 3 for our y2 minus y1 over negative 1 minus 5. So be careful with negative signs. 5 minus 3 is 8. So again, we'll end up with negative 4 on 3 is equal to the gradient of our line. So that means tan theta equals negative 4 on 3. To work out theta, we use our tan inverse relationship, and that'll come up with an angle of negative 53 degrees. So again, if we have a quick look, not the greatest of lines there, a quick look at our axes, plot the points roughly, and we'll see that the straight line there of that equation has a gradient of negative 4 on 3. So the 53 degrees is the angle below the axis in the negative direction. We're looking for the angle in the positive direction, so the angle we want is 180 degrees minus that, because the total angles adds up to 180, which gives us 127 degrees. Moving straight into example 9, again we need to find the angle. We look at the points, they look a bit more confusing, but again the gradient is y2 minus y1, so we use that information, put in the points, label our points 1 and 2 again, and just be careful with the way in which we put the values in. So the y value b minus the y value a over the x value 3a minus the x value 3b. So if we look carefully, we can almost see a b minus a on top and bottom. So if we take out a common factor of negative 3, that'll enable us to write that as b minus a in the brackets on the bottom. And those two terms will cancel to leave me with negative 1 on 3. So tan theta is equal to negative 1 on 3. So again, theta is equal to tan inverse of that, which will give me an angle of negative 18.43 degrees. So because we get a negative angle, again, we must have a negative slope on our line, so that's going to be the angle below the axis. So if we just do a rough sketch of what it could look like, that negative 18.43 degrees is that angle there below the axis. We're looking for the positive angle, the angle in the positive x direction, which is the one above the axis. So again, 180 minus that angle. will give me 161.57 degrees.